Let's see here. This is what we learned last week. Logarithm properties. When you have two products here, you can rewrite this as log base a x log base a y. If you have this guy division, you can split this into these two minus. You have this to the power of m over this position. If you drag this m in front, if you have a here and a here, the result is just this. You have base a, you have a here, this is 1. This is true because this equals to itself. So a as the base, this as the exponent, x is going to be on this side. This is saying a to the power 1 equals to a. This is saying a to the power 0 is 1. If you have this fraction, you can also put this one to the very beginning. These are the basic properties we learned last week. Now we can look at these questions. Claire, let's go ahead to number 3, please. You want to do this first?
No.
These two.
Okay.
When you have this minus and they have the same base, if you don't write down any number here, by default it's 10. So this is who?
Wait, say that again?
Based on the property, this guy is who? You joined late last class, right?
No, I had a tournament last class. I couldn't join.
Oh, you didn't? Okay, so you didn't join the class.
Oh.
Okay. Let me do this. Let me explain these properties one more time. Look at this. You have log base ax minus log base ay. If you make this as m, if you say m equals this, n equals to this. Okay? So that means this part is m, this part is n. The left is m minus n, right? Yes.
Say that again?
This is m, this is n.
Yeah.
Make sense?
Yeah.
So x is who? Based on this definition, x is who?
A to the power of m.
X equals to a to the power of m. Y equals to who?
A to the power of n.
A to the power of n. Now, if I do x divided by y, x over y will be who over who?
A to the power of m over a to the power of n.
So if you have this
So
on the
a
top,
to the power of m minus n.
this is a to the power of m minus n. Make sense?
Yeah.
And then log a, and you put here as x over y. You put log a here, you put a to the power of m minus n. Who is this? Who is this? This should equals to exactly m minus n. Make sense?
Yeah.
Because a to the power of this equals to this. Just because this base to the power of this equals this. Okay?
Yeah. Mm-hmm.
So this is showing this property is true. When you have a quotient here, you can pull this in front and this one put here. This quotient become a difference when you want to split them. Okay?
Yeah.
And then when we go back to this question here, who is this?
Does the log not have a base?
This guy has a base. If the base is 10, you just write down log. If the base is 10, you don't need to write down. Just like this. By default, this is 2. If it's 2, you don't need to write. Same thing for here. If it's 10, you don't need to write. This means they have 10 base, you have 10 base. You have the formula that you do with me just now.
Oh, okay, so 12x over 3x?
This is x over y.
Yeah.
Correct?
Yeah.
So this
log
means 12x over 3x. Make sense?
Mm-hmm.
And then this is 10, this is log, and this is 4. This is 10. You don't need to write down 10, but if you write down 10 here, it's going to make you get the answer quickly. When you have 10 and 10, the result is just this. Because, why this is 4? Because look, do you agree that this equals to this itself? Is this true?
Yes.
And based on the exponential and log definition, that guy to the power of that guy is this guy. Make sense? That's the base. This is the exponent. This is the result. That's why this equals this. Make sense?
Makes sense.
Okay. Next one. Example 4. Christina, did you have a chance to take a look at the video last week?
Yeah.
Okay. So what do you think? How do you do this question?
First you can make the 36 to 6 squared.
Good. So you make 36 as 6 squared. And then you do 6 squared to the power of this, right?
Yeah. And then
a to the power of x to the power of y means a to the power of x times y. So you have 6 and you have 2 here. You have this. So far so good.
Yeah.
When we learn the log, you can pull this 2 to that 7th exponent position. You put this 2 on this shoulder. So you have one more step. 7 squared, right? Yes.
Yeah.
Again, this is 6. This is 6. So the result is
49.
49. That's it. Does anybody have a question over here? Next one. Catherine, let's do this. Tell me what you want to do. Two? What do you want to do too?
You put into log.
You can change 2 to a guy with base of 4. 2 is 4 to the power of who? Two is 4 to the power of 1/2, correct?
Oh, yes.
So you will put 4 here. And then you do 1/2. And you do log base 4 and 12 over here. So far so good?
Yes.
And then you will pull this one to the shoulder. you put this one to the shoulder. This make you 4 to the power of log base 4, 12 to the power 1/2, correct?
Yes.
4 and 4. This and this are the same, so the result will be who?
12. The square root of 12.
Square root 12. Simplify. This become?
2 root 3.
This is 2 times square root 3. Okay? Make sense?
Yes.
Okay. Valeria, let's do example 6. Go ahead, please.
So 25 is 5 squared.
This is 1. 1 is a special number. 1 is a special number. Do you know, for example, 25 to the power of who gave you a 1?
0.
Yes. So you write down this as 25 to the power 0. Make sense?
Yes.
And then this give you this equals to 0, right?
Yes.
Okay. So you put log base 5 here, x minus 2 equals to 0. And then your x minus 2 will be? X minus 2 will be 5 to the power 0, correct? This guy is 5 to the power 0, which is
1.
1. So x is
3.
3. Make sense?
Yes.
Okay. Example 7. Sudisha, let's do this one, please. We will solve this layer by layer. You see this guy. You have one number here so that this result give you a 1. What do you want to put here? In other words, log 2 here, what box you put here so that this result is 1?
0.
Hold on. Not true.
2.
Yes. When you see this, you always think that guy is base of 2, 2 to the power of this number. Okay? This is 2 to the power of this number. Make sense?
Yes.
So you have log base x here, 36, and then this is 2 to the power 1, which is 2, right?
Yes.
And then next, when you have this equals to 2, so this is a base. Who is exponents? X to the power who?
6 to the power 2.
So you say x to the power 2 equals to 36, right?
Yes.
X equals to positive 6. You don't want to put negative 6. The guy here is only allowed to be positive. When we draw the logarithm, remember, this is exponential growth. This is a to the power x when a is greater than 1. This guy, reciprocal, this guy, not reciprocal, inverse function is this. This is log base of ax. Okay?
Okay.
Your x has always be positive. Your a has to always be positive. So x is 6. Make sense?
Yes.
Next, Ethan. This number is a little bit longer, but you can do it. I want you to do this right part first.
Okay. So log 2 and
Who is this?
Mm,
In other words, you say, if you don't know, you put x. You will say 2 to the power x equals 1/2. X is,
mm. 1/2.
wait. You hold on,
Oh.
okay?
Wait.
You get lost. Abby, how much is this?
Is it -1?
Yes, that's right. This is -1. It's because 2 to the power -1 is 1 over 2 to the power 1, which is 1 over 2, right? And then, can you continue, Abby? You have this whole stuff equals -1. So this whole thing will equals to who?
1 over 4.
It's 4 to the power -1, right?
Yeah.
So you have this thing as 4 to the power -1, which is 1 over 4. Let's keep going. Based on this, that guy is who?
16 to the power of 1 over 4.
What does this mean?
2.
2, because this is, you put 4 here, and you want to do this radical roots. This is 2, because 2 to the power 4 is 16. So this is 2 right here. Next.
X equals 81.
Yes, 9 to the power 2 is 81. Exactly. Students already learned this. I don't want to repeat that. We will continue working on these questions. Now, Ethan, go ahead. Let's do number 5. Look at this.
So
When you see this thing, it is a little bit a headache because it has so many things, right?
yeah, so 27 could be written as 3 to the power 3. 3
Yes.
to the power 3 times
3 to the power 3 times
log 3.
log base 3, and then 9 to the power of log 3, 2 here. So far, so good.
Yeah. So 3.
And we will draw this 3 over here, right?
Yeah.
And this one will be put on this shoulder. So I'm going to write down every step so that students will not be lost. So you put 3 here, and you copy down this. And then you will pull this 3 to the power of that guy, right? Next, this is 3, this is 3, so this will cancel. The result is going to be just this. Make sense?
Yeah.
So far so good.
Yeah. And then 9 could be
A to the power x to the power y means a to the power of x times y. So you can do 9, and then you can put 3 in front times this. Correct?
Yeah.
Okay. So far so good.
Mm-hmm.
And then again, you can put this 9 as what?
3 to the power 3.
3 to the power 2. 3 to the power 2. So this is 3 to the power 2. So you will do 2 times 3 times log base 3 2 here. Make sense?
Yeah.
That guy is the guy you copy down here. 9 is 3 squared, so you put here. And then you will pull this one over here. The 6, you will pull this guy here. Make sense?
Yeah.
So you have 3, and then log base 3, and then 2, and then to the power 6. This equals?
2 to the power 6,
Yes. Which is
64. I mean 30.
64.
Yeah.
That's it. Does anybody need help for this question? You will do it layer by layer. 23 is 3 cube. And then you copy down or whatever else. And you pull this 3 over here. You pull 3 over here. And this 3 is 3 canceled. So you have this thing. You have this thing. And then you can pull this 3 in front here, which you have this. And this 9, you can do the 3 square. 3 square. You copy down everything else. And then, you know, this is 6. 6 will be pulled over here. This is 3, this is 3. It will balance. So this is 2 to the power 6, which is 64. Okay. Who want to do number 6? Is there any volunteer want to do number 6? Okay, let's go.
So you can do 12 to the power of log 12 and then 14 over 49.
Yes. This will become
12 to the power of log 12.
this 2
2
will balance canceled. So you have this,
Cancel.
right?
And then that's 2 over 7.
Yes. That's right. Okay. Number 3. Vanessa. Let's try number 3.
Yeah. So it's just 2 log fish to 3 times 15.
Yes.
45.
Yes.
Yeah, which is just 45.
Yes. Very good. You try one more. Let's do here.
So
You can pull this one here, okay?
yeah, so it's 2 and then log 2 and then 4 to 1/4.
Yes. Equals
Equals wait. 4 to the 1/4 is just
yes.
1. Wait,
Mm-mm.
yeah, it's oh wait no. Yeah, like 2 log 2 cancels out. Okay.
So this canceled. You will have this, but this is
Yeah.
not simple version. 4 is 2 square, right?
Yeah.
So 2 to the power 2, and then times 1/4. This is 2 to the power 1/2. So this is square root 2. Okay.
Yeah. Okay.
Very good. This one is easy. Just equals to 9. Okay. Students, if you didn't open your camera because you are in the car or because your internet issue, please let me know. If you can, please open so that I can call you to answer question, to do question with me together. Yeah, I know Joanna already told me. Annie, can you answer questions or not?
I'm sorry, I'm still in the car,
Oh, okay. That's fine.
but I'll tell you when I can.
Sure. Okay. Let's go back. 81. Christina, let's do 81. What do you want to do, Christina? You didn't unmute yourself yet.
You can do 3 to the power of
81 is 3 to the power what?
3.
No, 81 is not 3 to the power 3. 81 is 3 to the power 4, right?
Or 4, yeah.
Mm.
And then you can,
Right?
yeah,
And
then
then you will put this one on the shoulder, right?
yeah.
So this become
10 to the power of 4.
yes. That's it. Okay.
Okay.
Now let's go ahead solve the logarithm equations. Number 12. Valeria, let's do 12, please. Valeria, what can you do for this one? This is 3, this is 9. So you want to change this to be 9 to the power of
9 to the power of
1/2, right? Yes.
Yes.
Next, you want to pull this one to here, right?
Yes.
Right. And 9 cancel. So this become 2 who?
X plus 2 to the power of 1/2.
Yes. Equals?
Equals 4.
Yes. And then?
And you can square both sides.
So x plus 2
X
equals?
plus 2 equals 16.
X become?
14.
That's right. I'm going to let students, can y'all try do 13 and 15 by yourself? Make sure show me your work. Do every steps. Give it a try. Make sure convert this 6 to 36 to the power something, and then put that one over here. And then you do this one first. You solve this layer by layer until you reach to the most inner one. Very good, Annie. You got 13. Very good job, Joanna. Got correct. You got 13 correct. Very good job, Claire. You got 13 correct. Every step is perfect. If the logarithm question still bothers you, you text me a private message, okay? This concept, if you truly understand, it's not hard. Good job, Vanessa. That's correct for 13. Very good. Sudisha, that's correct. Very good. Christina, nice job. You got 15 correct. You got both correct. Very good, Catherine. You get also 15 correct. Excellent. Yeah, Valeria, very good. Oh, wow, we have students here all understand this part. Yes, good job, Annie. Yes, so good. I'm so happy. Student can handle this question pretty well. Does anybody need me to walk through with you for number 15? Don't feel shy. Anybody want to go through this question with me? I will go through with you. Vanessa, can we go through this question together, please?
Okay.
So first, we want to get this. Who is this?
It's 4 to the 1/3.
So this is 4 to the power 1/3, and this is
Yeah.
4. So this is 1/3, right?
Mhm.
Okay. And then this whole thing equals this. So that whole thing equals who?
Wait. Everything equals 8. So
8 to the power
To the
1/3, right? Yeah,
Mhm.
this is always a base. On this position, this is called the base. On this position, it's also called the base. So you have here, who is this?
it's 2.
2. This is 2.
Mhm.
And then we will put this one.
It's the 3 squared, right?
3
Yeah.
squared, which is
9.
9. Next, 6x
Okay.
equals,
8 to the 9th,
yes, which is
which is wait,
my birthday divided by 2. October 24 over 2.
wait, 512. I think. Yeah.
Yes. And x is this over 6.
Yeah.
Top one
Mhm.
divided by 2. Bottom one divided by 2. Okay.
Mhm.
Makes sense now?
Yeah.
Yeah, that's 15. Next. Number 19. Sudisha, let's do this one together. You have base of 2 here. As long as we convert this guy to the power of 2, we will be able to get this. Who is this?
2 times 4 to the power 1/3.
So this is 2 to the power of 2 over 3, correct?
Yes.
And this is 1, correct?
Yes.
And then plus this guy equals to 3. So this guy is 2 to the power of 1 plus, right?
Yes.
And then you have base 2 here, you have base 2 here, you have a plus. If we do this together, this is 2 to the power of 5 over 3. And then what we do?
Times x squared.
Yes, equals to 3, right?
Yes.
And then we have this guy times x squared equals to who? That guy is, this is the base, this is the exponents, right?
So 8.
Yes, but yes, this is 8, but we still say 2 to the power 3. Yes,
Yes.
because we want to divide it so that we can get x squared. Make sense?
Yes.
So you have this guy over this. And you do the 3 minus 5 over 3, which is?
4 over 3.
Yes. Make sense?
Yes.
And then you will have x equals
2 to the power 4 over 6.
yeah, which is 2 over 3, right?
Yes.
But here we can choose positive. We can also choose negative. Some students may feel confused. You already said this thing has to be positive. Why you say you can do negative? This reason here, because you have a square based on the operation priority. When you have this, you do that guy's square first, and then you do the log. So log a x squared. X could be positive, x could also be negative. That's why you can choose plus minus. But if you have cube here, you can only choose positive. If it's even, the thing here can be positive or negative. Okay, so there are 2 answers. Make sense?
Yes.
Okay. Any question for number 19? Number 20 and the number 21. Please do it by yourself. All the students, if you want me to call you to do question with you together, you just text me a private message. I will call your name. We will work on it together. Good job, Vanessa. Very good. When you have the final answer, you want to do one more step. The solution you solved just now, you want to plug in into each of them. You have to satisfy all the things here are positive, okay? You have to make sure you need to make this thing positive. Right, Christina, very good. And you have both questions correct. Vanessa, your work is good. You just missed the last step. You want to put it back to check, to verify. Ethan, you want to double check your work. Good job, Stisha. That's right. Good job, Catherine. Very good. You notice that you solve this, but when you put this back here or you put here, this makes this both negative. This is not possible. You will delete it because this is the original equation. The original equation has to satisfy the domain. But when you change this to this is quadratic equation. They are not identical. You can use this to solve, but you have to put it back to check, to confirm. Okay. Next, students, please work on number 23. When you finish, make sure you double check your work is correct. Joanna, you want to check 1/3. 1/3 is making this negative. So you cannot choose 1/3, only one solution, okay? Very good, Sudisha. You get both correct. Claire, make sure you put the restriction for number 20. You want to delete 1/3 answers. Valeria, that's right. And you also want to make sure you say 1/3 is wrong. Okay, that one cannot make this both happy. So only choose one. When you finish 20, 21, you can do 23. Ethan, very good. What's your last step? You have to put back to make this both parts positive. Please finish your last step and your work will be complete perfectly. Anybody want to do 23 with me together?
Did I do it?
Okay. Yes. This is 1. This is log base 10. This is log base 10. If we want to make this in one term, what can we do?
Wait, make it in one term.
So we want to make this log base 10, 10, right?
Oh yeah.
Okay. And then some people ask, can this 0 be here? No, that's impossible. The log, this is the vertical asymptote. You cannot make this equal 0. Okay. So this is log base 10, 10. This is log base 10, x squared minus 9. They have the same base, so you will have a log base 10. You can do this 2 guys multiplication. Make sense?
Yes.
Okay. And then what you do?
Log and then x minus 3 squared.
Yes. If there's nothing here, by default means 10. They have the same base. You will make the guy here the same. Let's go.
Oh, so 10 times x plus 3. Oh,
Hey, this is 10x squared, right? 10 times x
yeah.
squared minus 90, right? Equals that guy, right?
Yeah.
Let's expand this one. Who is this?
X squared minus 6x plus 9.
Yes. Let's move this around. Let's go.
9x squared plus 6x minus 99.
Plus 6x minus 99 equals to 0, right?
Yeah.
And then we take the 3 out. So this is
3x squared plus 2x minus 33.
equals 0, right?
Yeah.
That's factoring. 3 is 1 by 3. And then
Wait, and then -3 and then 11.
good. This become
11 minus 9 equals 2.
So that means, oops, I want to mix this up. So that means we have x minus 3 times 3x plus 11 equals 0, right?
Yeah.
X equals to 3.
3 and -11 over 3.
When we have this guy here, negative minus 3 is negative. This solution is not possible. When we have here, this is 0. Oh, this is 0. This is also 0. Log base 10, 0 doesn't exist because the logarithm graph, you have log you can choose any base, but all the base number here has to be positive. If you choose 2, for example, you put here this guy. You see, teacher, your graph showing x could be 0. No, x couldn't be 0. Y-axis is the asymptote. This asymptote couldn't be crossed, couldn't be touched. This x equals 0 never ever can make the x equals 0. That's impossible. So if you have a solution, make this guy equals 0. This is also no solution. None of them work. The answer is empty. You want to check? There is no solution. And you might wonder, then why this quadratic should give me the solution? It's because when quadratic do this, these two are not 100% equivalent. When you convert this to here, you just say, okay, as long as these two are equal, I'm fine. But for here, you have to make sure that guy has to be positive. It couldn't be 0. Even 0 cannot make this happen. It has to be pure positive. It's not just can be 0 or just positive. It has to be only positive, no zeros. So no solutions. And you may say, what will happen if I draw the line on the left, draw the line on the right? What will happen? You draw 1 plus log base 10, log base 10. Yeah, by default, if there's no number, that means log base 10. You do x squared minus 9. This is the first graph. And then your second graph is 2 times log base 10. And then parenthesis x minus 3. Okay? You say, oh my gosh, on this 3, they are like crossing anywhere. No, none of them can reach x to 3. X equals 3 doesn't exist for both lines. That's a vertical asymptote. It couldn't be crossed, so there's no solution. Any questions so far for 23? Any question? This question has no solution. Now we are going to move to different questions. This is something new. I haven't teach you guys this yet. Okay. Wait. Ethan, you can unmute yourself. This is 1 by 11, which is 11 minus 9 is 2. So you have this. The result is negative. You say positive. How do you get that positive?
What do you mean by positive?
Your result, the work you sent to me is, oh, you have negative. Yes. Negative is not working. Why you mean it's working? Negative minus 3 is negative. This part has to be positive. What do you mean this?
The 2, when you move the 2 to be the square root.
Oh, no. It's not. This guy, you leave here or you leave there are not 100 equivalent.
Okay.
So this is the problem. It's not your mistake, but it's very confusing. It is operation order. It depends on what you do first, what you do second. Because if you do log base 10 and you do x minus 3, if you do square, this two, anyway. If you put the square here, if you write down square here, suppose this thing can be positive, can be negative. After square, it is positive. But if you have the 2 in front, the thing here, x minus 3, has to be positive. Okay? Yeah. Even though you can write down here to solve it, but when you put it into the original one, this thing still has to be positive. Okay. Next, this is something new. First, I show a simple one. You have this. E to the power of x is 9 divided by 6. 9 over 3 is 3. 6 over 3 is 2. And then you can say x is log base of e and 3 over 2. You can also say this is ln. Ln is natural log, and you do 3 over 2. Okay, you can do this way, you can do this way. Simple. If you do example 3, this is 7 to the power of x over 3, which is e. You want to solve your x. So this is, if you use base of 7, you put e here. This is equal. This exponent equals to base of 7, and e is over here. So x is 3 times this. But for example 4, you have x here, you have x here. You won't be able to solve the x easily. So you will do a natural log, or you will do the log base of 10 for both sides. That means if you do natural log, Sudisha, if I want to solve this equation, I will do the natural log for both sides. Same base. This is still equal, right?
Yes.
And then you will put this x in front. And you will put 2x plus 3 in front, right?
Yes.
Okay. And you have this. And then this is x times ln of 9. This is x times 2 times ln of 8 plus 3 times ln of 8. Okay? And then you will move this guy to the left. So you will have x ln of 9 minus 2 times ln of 8 equals 3 times ln of 8. And then your x is equals to 3 times ln of 8 over this. Does this make sense?
Yes.
That's the new thing today. Does anybody need help? We will do the next question. Look at this. If you want to do with me, just unmute yourself. Let's do this one together. Who want to do next one?
Can I do it?
Okay. Go ahead. You want to choose natural log or you want to choose log base 10?
Log, like the second one.
So you want to use log or you want to use ln, which is natural log.
Log.
Okay. Log means log base 10. Okay. So you just write down log and you put here. You just write down log and you put over here. So far, so good?
Yeah.
And you will pull this one in front. Make sense? And then who is this?
3x minus 2
Times.
log 4.
Good. And then let's do this. Go ahead.
Log 6 times x, and then plus log 6 equals 3 log 4x minus 2 log 4.
Good. You will move the x term to the left. You will move the constant term to the other side. Go ahead, please.
So log 6 minus 3 log 4, and then times x equals negative 2 log 4, and then minus log 6.
Good. And then x equals?
Negative 2 log 4 minus log 6 over log 6 minus 3 log 4.
Good. That's it. Makes sense?
Yeah.
Who want to do number 6? Oh, Ethan, yes, you told me just now. Let's go ahead to this one together. You can choose natural log also, okay?
Okay. So ln 5 to the power of x plus 2 goes to ln e to the power of 2x plus 3.
Minus
3.
3. Keep going.
Oh, ln 5 to the power of x plus 2 equals to 2x minus 3.
Because ln of e
Yes.
equals to 1. Okay? Now let's go do this distribution.
ln 5 times x plus ln 2 times ln equals 2x minus 3. So ln 2x minus ln 5 times x divided by 2x minus 3 equals to negative ln of 25.
So far, so good.
Yeah.
And we will take out x. We will have this, right? And then x is equals to
Negative 3 minus 2 ln 5 divided by ln 5 minus 2.
okay. That's it. You might wonder, well, what does this mean? Why we need to solve this? So you can see on the left is 5 to the power of x plus 2. This is the graph on the left. The other one is e to the power of 2x minus 3. You have this too. And you want to solve their crossing point. Okay? And then the way you solve it by graph calculator, it's really hard. But when you have this two, you can have the x location. So you can do this. You will do this fraction minus 3 minus 2 times ln, which is the natural log of phi, divided by ln of phi. And then minus 2. Okay. It's crazy. This one doesn't show over here. Yeah, but our answer is correct. I think it meets somewhere there over the top, which is really hard to get to see it. I need to get the 15. Yeah, because the graph here, phi to the power something, is going to make it really steep. So it's really hard for you to see the crossing point. So if we change this, if we change this way, we will be easily, because look, if you want to graph this and this, you want to solve, you want to find the crossing point, because the guy, this exponential growth is really, really high. It's hard for you to have the curve. But if you do a natural log, you draw this and you draw this, it's easy for you. So what you do? You will do x plus 2 times ln of phi. Right here. So this is the equations left. Yeah, this curve make more sense because the previous curve is increasing exponentially. So it's really hard for you to look at the scale of those from 0 to 100. Even you put 100, even you put 10,000, you still have trouble to find out when x close to that 15 number. Because imagine 5 to the power of 15 or 17 is going to be really huge already. So this one is your left, and 2x minus 3. Ta-da, that's it, that's it. Right, yeah, and previously you want to figure out that curve. This is curve growing like this. When your x is 15, it's going to be a huge number, you know, 15.9. You can calculate phi to the power of 15.9 plus 2 is 17.9. You see, huge number. You won't be able to see it in this scale unless you do the natural log for both sides. Okay. Any question so far? This kind of question is interesting. If you learn the AP computer science, you might see something similar to this kind of thing. Yeah. The natural log, all those exponential, this kind of exponential thing grow too fast. If you want to solve this equation by solving this two curve crossing point, all of them is so steep. You won't be able to solve the solution easily. So you will take the natural log, which makes the steep curve kind of mild so that you can find the crossing point. Who want to try next? Number 7. Everybody understand how to do this? Nobody want to try? Then you do by yourself. Number 7. Send me your work when you finish. You might wonder, if I choose log base 10 or natural log, do I have the same answer? Finally, yes. When you get those decimal, you will have the same answer if you do both ways correct. Claire, something wrong. The first step, you have 3 times it. So you will do the lien for both. Why your 3 doesn't have this lien? You have lien of this and the lien of this. So you have a lien of 3 plus 3x minus 1 times lien of 2. Your first step is wrong. Can you redo it? Clear. Actually, let's do this one together. You want to choose natural log or you want to use log base 10?
Natural log.
So you will do this, right?
Yeah.
And then this is multiplication, so you will split.
So ln plus.
Yes.
3 plus ln. 2 to the power of 3x minus 1.
Yeah.
And then you can take the x plus 1 down.
Yes. Okay. And then you have this guy here. You have 3x minus 1 in front. So far, so good?
Yeah, so far so good.
And then you will do the
You would multiply
distribution.
it out.
Yes.
So ln 6 times x plus ln 6.
Yes. And then you will do this thing also.
So ln 3 plus 3x times ln 2 minus ln 2.
And you want to move around. You want to move the x term to one side You want to move the other thing to the other side.
So 3 times ln 2 times x
I
minus
will just do this. Okay.
Mm.
Equals
ln 3 plus or negative
plus ln2 and minus ln3.
minus ln 3.
Okay. And do you know who is this?
It's
That's 12 divided by 3. That's ln of 4.
ln 4.
Okay. Makes sense?
Oh, makes sense.
All right. So you
So
can copy down that. And then you have x equals to
ln 4 over
yes.
all of that.
Makes sense now?
Yeah.
Okay. Yeah, some of you know that I have 3 girls. My eldest girl is a senior in Clements. Yeah, so you know all the kids in Clements suffer so much, but not for the senior year. Yeah, so think about this. By the time you go to 12th grade, at this moment, looking forward, in your senior year, you will not worry about your grade. You can just relax, okay? Work hard, and one day you can relax. That's the answer. Let me check other students' work. I have so many different answers here. Anybody, if you need to ask me, do this with you again, please. Anybody need help for this question? First, you do the natural log for this whole thing. And you split this. And you pull this in front. And you do this distribution. And you put the x term to the left. You put the cos term to the right. Okay. Okay, I need to teach one more formula. This is called a base change rule. We already learned so many properties, but today I have to teach you guys another formula. This is called a base change rule. This is one of the most important formula for the logarithm. Or maybe this is the #1 important formula for logarithm. This formula is saying, if you have log base a of x, if I want to switch this to another guy, say b, this is going to make your b here, and you put the x here, a here. This will be equal. In other words, you can say b is 10, so this is the base of 10, log base 10x, log base 10a. If you choose your b as the natural log, then you will have a ln x over ln of a. This way also work. I say, no, this couldn't be correct. Look at this. You will see, you will see, you will understand, you will trust. So, for example, if I do log base of 7, and then here I have a big number, okay? I have a huge number. This is the answer. Based on this base change rule, what I can do, I can say, I'm going to change the log log base 10. So I'm going to use 852,971 over log base 10, 7. You see, this is exactly the same answer. You might say, no, you are doing some tricks there. No, I'm not. It's always true. If you say, I changed this to be the ln, I choose this natural log, and I choose this to be the natural log. Oh my gosh, it's still correct. Okay, now you see that guy equals this. But you say, oh no, you only choose this. You only show this is true. You only show this is true. You didn't show this is true. I'm going to prove. I'm going to let you see why this is always true, forever true. You still make M as this. M is the definition of this. So based on the log definition, X will be a to the power of M. After you make X equals a to the power of M, your log base bx. X is replaced by a to the power of M. And you can pull this M in front. That's our log properties. So you have here. Now look at this. Log base bx. X is a to the power of M. So M will be pulled in front. So you have here. And then the bottom log base b of a. These two are identical. Let them go. So this is M. This M is this. Wow. Your B could be any positive number. So your B could be 10, which is that scenario. Your B could be E, that's this scenario. So this is a famous base change rule. Okay, this is famous base change rule. Why we need to do this? Because not always you have a smart calculator. For the smart calculator, you are able to do any base. But for the dumb calculator, you can only choose your base of 10 or base of E. So if you don't have the smart calculator to calculate the loss base 11, loss base 10,005, you have to use this formula to do the conversion. This is called a base change rule. Base change rule. Any questions so far? Okay. Now we want to do some words problem. We learned those growth decay in Algebra 1. We also know something about compound interest, but we didn't go very deep in Algebra 1. So this is a part we want to go deep. Just remember, this is all those like virus, bacterial growth, or sometimes some elements decay, okay? And this guy is a continuous compound interest, saying you put your $10,000 in the bank, and the bank is recalculating your new balance every day. That's called a continuous compound interest. And then at the end of T days, what's your money? This is using that formula. The initial money times e to the power rate times the amount of time. Compound interest. If you have yearly, annually interest rate, you just 1 plus r times to the power of n. But if it's interest monthly, you will use the year rate divided by 12, and you do 12 times t. Okay. Appreciation, like your house price is increasing, depreciation, like your car price, from the first day you buy it, the value is decreasing. That's a basic model. You might already see this in your Algebra 1. And then let's do a few questions here. So the model here, they are using invest this, and this is called compound continuously. And they want you to see how long does it take to make the money worth of $10,000. So the correct formula on this list is exactly that guy. Actually, these two guys are so similar. So this one, Abby, based on these numbers, tell me what equation you want to put here to solve the T.
Wait, so 3,000 equals, wait, no. Wait, A equals 3,000.
8? What's
A.
the A? Oh, A, okay. So the ending money, right?
Oh, 10,000.
Yeah, this is ending money. So 10,000 equals
3,000
times
time, wait,
E.
wait,
This is the
Okay.
rate, yes?
yeah,
0.072, right?
yes,
Times T. Make sense?
yes.
And then we can solve this. What's the reason we learned the log is when we want to solve the real world problem. So we can do this 10,000 over 3,000 is 10 over 3. Yes.
Yes,
And then you can take the natural log. When you do the natural log, you do ln of 10 over 3. Yeah. And you do the ln over here. Ln of E is 1. You put this in front. So this equals to 0.072 T. Make sense?
yes,
And T is going to equal to ln of 10 over 3 divided by 0.072. Okay? Does that make sense?
yeah,
Yeah. And then you can use your calculator to solve. Yeah. This is the continuous compound interest. That means every day the bank gave you this kind of interest rate. So every day they are going to recalculate your new balance. Every day there is interest. And next day is going to based on yesterday's original money plus interest. And that's the base money. You will count your interest again. That's called compound continuously. It is using this formula. Most time we are not lucky. There's no bank give us such kind of compound continuously. We most time get those compound yearly. Or maybe some bank give you those compound quarterly. 3 months, they recalculate the balance. This is compound quarterly. That means you have this rate 0.082. This is 0.082. Doesn't compound continuously make the bank more money? No, Ethan, the way it's not working that way. It's this. So for example, they give you 0.07. This is saying 7% interest rate, right? You have $10,000 initially. If most time they don't give you compound continuously, it's going to be annually. So you do 1 plus 0.07 0.07 to the power. For example, you put this money in the bank for 5 years. So you will see the money for 5 years. You will see this give you how much? You have $10,000 times 1.07 to the power of 5. Okay, so in 5 years, you have, you have this amount of money. And if you say, I have this compound interest continuously, then you will use this guy times e to the power of 0.07 times this. But let's see here. Okay, that's the result. If you do compound continuously, that's the money you have after 5 years. If you do compound yearly, you have this. If you do compound semi-annually, you do 1 plus 0.07 over 2. And then 5 times 2. This is compound semi-annually. So we can do this 10,000 times 1 plus 0.035. But because it's count your interest every half year, so you have this compound happen for 10 times. So you will do this to the power of 10. Okay? So you will have this amount of money. Okay?
Yeah.
Yeah. Does this answer your question?
And still compounded continuously, make bank more
Yeah.
money.
Yeah, but not too much difference. It's not too much difference is because number one, 5 years is not too much. Number two, this rate is not very high. But if you borrow the money, like you own credit card company, they charge you 25% rate, then that's going to be a huge difference. You see what I mean? Yeah. If you change this to be 25, you see, oh my gosh, it's triple times, right? Yeah. Yeah, because when the bank gave you the interest, they give you small one. But if you borrow the money from the bank, they will charge you way more higher. That's how the bank make money. The way they make money is because they charge people way more higher rate than they allow people to borrow from them. But when people deposit money there, they give them very low rate. That's how they make money. Yeah, because if you want to buy a car, you say, oh, if I don't borrow the bank any money, I will not lose any money from the bank. No, because you won't be able to afford the house, the total amount. You can only pay the down payment. And each month you have to pay the principal amount, you have to pay the interest. Same thing like you buy a car. If you have all the money from your parents, that's good, but most times parents cannot afford you for everything. You have to earn your own money, you have to pay the interest rate to the bank. That makes sense now? So let's see. I already show examples. I want to see if students can do the number 2 correct. This is compound quarterly, means you have the compound 4 times. The formula is 1 plus r divided by 4, and then 4 times t. R is this. Okay, and do this. See how much is the money after how many years the money will double. Yeah, so for example, you have $1 you put in the bank. and you want to change this to $2, and you want to figure out after how long based on this interest rate. Go ahead, do number 2. And you can also do number 3. If you need help, listen me or want to work with me, unmute yourself. I do number 2, number 3 with you together.
Can you work with me, please?
Okay, let's do number 2. You want to make some money double, right?
Yes.
So which formula you want to use?
Compound interest?
So that one, right?
Yes.
And you have the rate of 8.2%. So the R is 0.082, right?
Yes.
You don't know how much money if you put, say, P dollars, and you want to change this to be 2P dollars, right?
Yes.
So 2P is a new, P is old, right?
Yes.
You want to do what for here?
1 plus 0.082 over 4.
Yes. To the power of?
14.
The 4 times T, correct?
Yes.
If you have, say, T years, 1 year, you compound 4 times, so you have 4T. And then 2P over P is 2. So you have 2 equals to 1. This is 0.021. So this is 1.021, right?
Yes.
So 4T is cool. We are using the log concept. Log base who? This is the base, right?
Yes.
And here. And then, you know, after we learn this, you can use this formula to predict. For example, if now you have a $3,000 from your grandparents and your parents, and you want to calculate, if you don't touch that money and you put it into a bank, you want to see after how many years you can reach to $30,000. Okay, and you put a log base of 1.021, and you have a 2 here. No, you have a 2 inside this one, and then you divide by 4. So this is about 8.33 years, right? Make sense?
Yes.
Oh, yeah, that's true. My calculation here is a little bit wrong. 10205, correct? Yeah.
Yes.
Now I want to change this 1.0205. Okay.
Okay.
So this is after 8.50 years. Okay.
Okay.
You know, it's really hard to earn some money, but it's so easy to lose all your money because since the war in the Ukraine, the stock market is really, really bad. Lots of people lose a lot of money just because of this war. And a lot of people lose their life also. But if you want to get your money double with such a good interest rate, it takes 8 years. But I tell you, there's no bank give you such high rate. Most banks just give you full percent. So you can calculate. If it's a full percent, it takes how many years? It's an interesting question. So I always suggest kids don't waste money. I always ask my kids don't waste money because you do this calculation if you see if bank only give you 4% interest rate, see how many years you can make it double. You have 2p equals to 1p, so 2 equals 1 times 1 plus 0.04 over 4 to the power 4t. So 4t is log base of 1.01, base of 1.012. So if you see, if I change this guy to be 1.01, yeah, and then 2. 17. Yes, this takes 17 years. Did you see? With the normal bank interest rate, which is 4%. You know, last 2 years, the bank interest rate is only like 0 or 1%. Only this year, the rate increased by 4%. So it takes you for 17 years to make your saving double if you don't put any new money in this account. But for the stock market, you can lose all of your money in just one day. You heard of recent news, right? The Silicon Bank bankrupt. A lot of people over a sudden one night cannot get all their money out of their bank account. That's crazy. So you guys should have some financial ideas. When you save your money, you have to check if your bank support this FDIC policy. That means even the bank get bankrupt, you still can get your money back. Okay? Yeah. Now you can see it's so hard, 17 years to make your bank double, but it takes just one day to lose all your money in the stock market. Next, this one. Okay, we are already running out of time. Next class, I will continue teach because this part has a lot of topic. We need to learn those appreciation, depreciation, and also the half-life. So I will teach this next class. We still have many practice, you see, it's a lot. So I will teach this next week. So if you still have questions in this worksheet, don't worry, we will revisit. If you have a question for this two part, you stay with me. Or if you don't understand last week's class, you stay with me. That's for today's class. See you next week.